In this problem we're taking a look at the ozonolysis of a couple of alkenes. Okay, and just so you know what the structure of ozone is, at least one of the resonance structures, looks kind of like this. And what happens is this ozone adds into the alkene to give what's called a malozonide, which then rearranges to an ozonide, and then on addition of DMS, it gets cleaved into aldehyde or ketone products. Now we're not going to look too closely into the mechanism of this, but we're basically just going to try to figure out what products are formed. And the thing to keep in mind is that ozone cleaves all of the alkenes in a molecule. So here we have one alkene, right, and essentially that ozone is going to cleave right through that alkene. And each end of this alkene is going to get replaced by an oxygen. So one way to almost think of it is on this fragment we're going to get a double bond to an oxygen. On this fragment we're going to get a double bond to an oxygen. Okay, so we end up, if we want to number our carbons, just to keep track of things, we'll get carbon 1 and carbon 2 double bonded to an oxygen. We'll have our other fragment, which has carbon 3 double bonded to an oxygen, carbon 4, and carbon 5. Okay, so if we draw this out, we get carbons 1 and 2 double bonded to an oxygen. So there's our first fragment. So we cleave between carbons 2 and 3. So on our second fragment, we have carbons 3, 4, and 5, and 3 is double bonded to an oxygen. And we get these two fragments, and in this case, since we had just mono-substituted alkene on both sides, we end up with aldehyde products. Now this second example was a little more complex, and the first thing I'm going to do is I'm just going to arbitrarily number all of the carbons in this structure. So that'll let us keep track of our carbons. We have 8 of them, and we should have 8 carbons in the products. And what we're going to do is we're going to cleave at this alkene, and we're going to cleave at this alkene. Because remember, you cleave all the alkenes in the product. Now to try to keep this simple, I'm going to draw this main carbon framework pretty much intact, except I'm just going to break apart these alkenes. So we know we broke between carbons 1 and 2. So here's a double bond O, and we have carbon 2 connected to carbon 3. Okay, and carbon 3 should have a double bond O connected to it where we broke. And then that's connected to carbon 4, which is connected to carbon 5, which I'm going to exaggerate this a little bit, but that's connected to carbon 6, which is connected to carbon 7. Now, carbon 7 should have a double bond O connected to it from this ozonolysis. Then carbon 7 is connected to carbon 8, And then carbon 8 is actually connected to what we numbered as carbon 1, which we have a double bond O on carbon 1. So there's 8 and 1. So carbons 1 and 2 became aldehydes, carbons 3 and 7 became ketones. Now while this might not be a very pretty picture, it is an accurate representation of the product we obtained from this reaction. And if we count our carbons, we still have a total of 8 carbons in our product. And this is an oxidation because we've added oxygen into the product.